Okay, so we've started our wave function and we've found that we know that what we're starting with is we're starting with a sine wave and we're adding a cos wave and we're combining them to get either sine, k sine of x plus or minus alpha or k cos of x plus or minus alpha. And we've found that we know that k is equal to the square root of a squared plus b squared. And we know that to find that we've got to have the tan alpha is equal to k sine alpha, k sine, over k cos alpha, which gives us our values. Okay, so we've got those kind of bits and pieces and we've got to combine this together with what we've been doing before. We should kind of be thinking that this looks an awful lot like the double angle formula that we've got. Yeah, because we've got k, without the k, we've got sine of two angles, and we've been doing our double angle formula with those, so we should be seeing that this is kind of where it's headed. Okay, so it depends in the question. They will ask you, or they'll tell you to put it into a specific form. So they'll tell you to put it into either k sine of x plus alpha, or they'll tell you to put it into k sine of x minus alpha, or they'll tell you to put it into k cos of x plus alpha. Get the idea? Or they'll tell you to put it into k cos of x minus alpha. So the question tells you which form you want to put it in. Okay, so for an example, we'll go through this as an example to explain what we're doing. So we've been asked in the question to write 3 cos of x plus 4 sine x in the form of k cos of x minus alpha, and we're told that k has to be greater than 0 and the alpha has got to be between 0 and 360 degrees. Right, so where we're going to start. So as always, we take the information we know from our question. So we know that 3 cos x plus 4 sine x, we've got to write it into that form, so we know that it's equal to k cos of x minus alpha. Okay? There's nothing here we can do other than expand our double bracket. So here we've got the x and we've got the alpha, and so we can expand this out. So a little reminder is that cos of a minus b is equal to cos a cos b plus sine a sine b. So that's the expansion we're using for this, and we can't forget the sine ones either, because sometimes that'll be what we need to use. Okay, so we've got a k in front of it, so we've got the k, and then we're going to have cos, and instead of a, we've got x, and instead of b, we've got alpha, so cos x cos alpha plus sine x sine alpha. Okay, we can multiply out the k, so we get k cos alpha cos x. I've just turned those around just for ease, and k sine alpha sine x. So you can see we're starting to get towards something that we need. So up here, we know that we need k sine alpha and we need k cos alpha, and we need values for those to find our alpha and to find our k, don't we? So if we look here, this is why I kind of rearranged it a little bit. We have k cos alpha here. Okay? But that's kind of in front of our cos x. So in front of our cos x, we have a 3. And we know that k and alpha are just numbers. So, because we're trying to find the value of them, they're just numbers, so we know that k cos alpha is equal to 3. So that's our first place we can start. So we know that k cos alpha is equal to 3. So we're equating our variables. That's what we call this in technical terms, is equating variables. Okay, so we'll look to equate the variables for the sin x as well. So in front of our sin x, we've got k sine alpha, and in front of our sin x up here, we've got 4. So we can say that we know that k sine alpha has got to equal 4. Because these equations have got to be the same. So we know, once we've kind of multiplied them out, that these equations have got to be equal. So that means that those numbers have got to be equal. So we can now find our k and our alpha. So to find our k, it's equal to the square root of our a squared plus b squared, where our a and our b are our values for k cos alpha and k sine alpha. So we get the square root of 3 squared plus 4 squared. We should know from our Pythagoras and from an example in the last video that that'll give us 5, because it'll be 25, and that's what we get. And we also know that tan alpha is equal to k sine alpha over k cos alpha. So that is going to be 4 over 3. Okay, so we know that alpha is tan to the minus 1 of 4 over 3, and because they're both positive, it's got to be in the first quadrant. So we get 53.1 degrees. So we've ended up with the same question as we had before in the last video, but that's okay. So then we can rearrange it. So over here we kind of need to write it out. So we're going to get 3 cos x plus 4 sin x is going to be equal to, we know that k is 5, cos of x minus 53.1 degrees. Okay, right, so we're going to do one more example, and that'll be us for this one, okay? And I'm going to do an example with radians. Okay, so for this question, we've been asked to write cos of x minus the square root of 3 sin x in the form of k sine of x minus alpha. Okay, so we've been told where a has got to be between 0 and 2 pi, and k has got to be greater than 0. Okay, so again, take what we know from the question. So we know that we've got cos x minus the square root of 3 sin x, and we've got to equate that to k sine of x minus alpha. So our little thing we've got to remember is we know that sine of a plus minus b gives us sine a cos b, take away cos a sine b. Okay, so that's what we're using here. So we multiply this out, we can put the k at the front, so we're going to get k sine, our a is our x, our b is our alpha, so we're going to get sine x cos alpha, take away cos, and we've got the k in there as well, can't forget that, k cos of x sine of alpha. So this time we're equating. So if we look here in our first one, we've got our sine x and we've got our k cos alpha in front of our sine x. So that means that k cos alpha is equal to this, which is our minus root 3. So we're going to have that, put it down here, k cos alpha is equal to negative root 3. And then if we look at our second one, we've got our k and we've got our sine alpha over here, and in front of our cos x we've got nothing, but we've got a minus here. So we should know that when we've got nothing, that's not really nothing, that is a 1. So we know that we've got minus k sine alpha is equal to 1. So we can divide both sides by -1 to get that we know that k sine alpha is minus 1. So we can start here. K is equal to the square root of a squared plus b squared. So we get the square root of minus root 3 squared plus minus 1 squared. So if you've got anything under a square root and you square it, all that happens is the square root vanishes. They cancel each other out. And we've got a minus, and you're squaring it, it becomes positive, so we get 3. And then here we've got 1 minus 1 squared, which is just 1. So we get the square root of 4, so we get that k is 2. And then our cast diagram is going to have to come out for this one. ASTC, Amanda says trig is cool, that's the way I write it. So we know that k sine of alpha is negative, so that's got to be these two quadrants. And we know that k cos of alpha is also negative, so that's got to be those two quadrants. Okay, and this is the kind of question that we're going to be doing without a calculator. So we know that tan of alpha is equal to k sine alpha over k cos alpha. So we're going to have minus 1 over minus root 3. So we just get the negatives cancel out, 1 over root 3. So we need to figure out what angle are we going to get if we do tan to the minus 1 of 1 over root 3. And that's actually not as our alpha, it's our relative acute angle. Okay, so if we think, what triangle have we got that's got our 1, our 2, and our root 3? So tan is opposite over adjacent, so it's opposite over adjacent, so it's got to be this angle in here. So we know that that would be 30 degrees, but 30 degrees is how many radians? Okay, so if you think about it, how many 30s can we fit into 180? We can fit 6, so it's pi divided by 6. So our relative acute angle is pi over 6. But we know that we've got to be in our third quadrant, so alpha is going to be, we've got to add that on, don't we? So it's going to be pi plus pi over 6. So that's going to be 7 pi over 6. So then we can go back to our original thing up here, and we can say that we know that k is 2, and we know that sine, and then we're going to have x take away 7 pi over 6. And that's our answer. Okay, so hopefully wave function questions, you'll be alright. Don't worry, we will be coming back to them later in the course. You're not going to get away from them. Okay, but that's all we need to know with wave functions for now.